Most AllegroHDL users know the pain of adding connections to devices in the tool. It can be a tremendous time sink. This demo shows the groundbreaking approach the pinWire and dalAlign apps in the CeHDL suite from dalTools and CadEnhance bring to the user. Let's jump right in. On the first schematic page, we have three symbols drawn for our Xilinx UltraScale part, which includes all the transceivers that are required to connect a Gen 3x16 PCIe interface. These symbols were generated by the CadEnhance part builder tool using the Xilinx physical flow. The pin names on the part represent the physical names for the part provided by the Xilinx package file. Normally, the engineer's task would be to browse through the Xilinx pad report and figure out where each PCIe pin connects, and then make the individual connections. Not with pinWire. Here we configure pinWire to read the Xilinx pad report for us, and then make the connections itself. We surround the three symbols and drag out to the left to make the input connections, and then we run pinWire again on the other side of the symbols and set the position on the right for the output connections. We notice here that many pins remain unconnected. These are the pins that are not used in the FPGA pin report. Let's look quickly at how the signals got named. We can see that the pin names are bust, and they have the PCIe RXP and PCIe TXP and the PCIe ref clock pin names. These were found in the FPGA pad report. When you select the symbol, pinWire goes through a bunch of sanity checks to make sure that this symbol is actually associated with the pin report that you chose. Now we jump to another page where we have the I/O block in which the FPGA management pins are placed. We will add the connections here as well. Since we have the box to skip connecting power pins checked, pinWire will not add a wire to a power pin. You probably want to make an individual connection and connect all the power pins together yourself. More on that later. Let's zoom in and take a quick look to see how pinWire named the FPGA pins for us. To manually add these scattered wires with individual pin names for just these two I/O banks by browsing through the FPGA pin report would probably have taken at least 45 minutes, and then to double check the pin connections would take another 30 minutes. We can also see that pinWire figured out the pin type for each pin and placed the proper off-page symbol, input, output, or BiDi, connected to each wire. Now let's move to the block where the same FPGA was created using Part Builder with the Xilinx logical flow. Here the pin names are taken first from the Xilinx pad file and then from the Xilinx package file if the pins are not used. The advantages of this flow are numerous, starting with the fact that the schematic is so much easier to read and check. And just as important, the schematic connections don't change if the pinout changes. You only have to update the symbols and refresh the schematic. In this case, for pinWire, we don't use the FPGA pin report as the source for pin names. We use the actual pin name from the symbol. Now we will make the connections for the PCIe block, which is contained all in one symbol, and where we can see the pin names are much more straightforward. We can also see again that pinWire created vector signals for all the bust pin names it found on the symbol, which makes it so much easier to connect in the schematic. Now we will hook up the management symbol created from the Xilinx logical flow, which again has all the pin names from the pin report, so it is very clear what the intent and purpose of each pin is. pinWire will name the pins using the pin name from the symbol and will connect the appropriate off-page by looking at the pin type of the symbol pin. Now let's look at the power of the pin rename rules. We will make connections on this small 3-port PCIe analog switch and rename the wires attached to the B pins to PCIe switch P0, the C pins to PCIe switch P1, and the A pins to host PCIe. We can add comma-separated match/replace rules in the pin rename rules entry, or we can enter a file name that contains a whole list of match-replace rules. Let's look at the resulting pin names. Notice how the bus digits automatically get moved to the end, and they get named as a vector to make it easy to hook up as a bus in the schematic. pinWire also works with hierarchical blocks, where it gets the pin types from the entity files created for those blocks. The prefix and suffix entries can help you easily connect multiple instances of the same block in your design. Here we connect an F0 instance and an F1 instance of the same hierarchical block. When we finish, we'll zoom in to see the F0 prefix and the F1 prefix on the wire names. Last, we demonstrate the power of the CadEnhance Align tool, which lets us move whole groups of off pages to line them up with each other, and do the same with sig names. We surround a selected group of off pages, and we hit the spot where we want to align them. We surround a group of sig names, and we click the spot where we want to align them. We do this to both sides, and the Align tool provides an efficient means to clean up the schematic to provide a professional published look in mere seconds. Thanks for watching this video demonstrating the power of dalTools and CadEnhance CadEnhance suite for AllegroHDL schematic development. I think the performance speaks for itself. Please view the other CadEnhance demo/tutorial videos available at scast.cadenhance.com and download the complete CadEnhance tool suite from www.cadenhance.com/free tool downloads. We would be pleased to provide you with a free 30-day trial of our fully functional tools. The CadEnhance suite is available for download at www.daltools.com.